Hey there, Year 11. So this is now finally moving to Chapter 5's core content that you'll need to know. This area now looks at what a function is and what a relation is. If you remember my previous video in exercise 5b, which we talk about what is a relation. And I previously mentioned that a relation, is a set of ordered pairs based on what they're saying here. Relation is a set of ordered pairs there. I'm just going to rub it out so you can see what I mean. A relation is a set of ordered pairs. I said that as long as you've got a set of coordinates, so this is a set of coordinates, doesn't matter what set of coordinates, that becomes a relation. But today we're going to be looking at what is a function then. So since I said that a relation is a set of coordinates, right? But a function is specifically when, in those random set of coordinates that you have, that they have this one property, this one idea. Only one corresponding y value for every x value. Now that may sound confusing at the start, but let's say it again. A relation is a set of coordinates. So you can have 1, 2, you can have 3, 4, you can have 5, 7, you can have the coordinate 3, 6, That together in this group, this is called a relation. So if you put this onto a Cartesian plane, so if we were to draw a Cartesian plane, and we were to put these coordinates as an example, right? Let's see, I'm just going to quickly roughly put them somewhere. So 1, 2, 1, 2. That's my first coordinate, 1, 2. The other was 3, 4. So 3, 4. Look, I'm not trying to be accurate in terms of my axes here. So 5, 7. I'm just trying to illustrate a point. And 3, 6. So 3, 6. Say there. Okay. Now, that's a set of coordinates. That's a relation. What is a function then? So we said that a function, for every x value, there is only one corresponding y value. Now, let's have a look at this relation that I have. Is it a function? So everything is a set of coordinates is a relation, but not all of them is a function. So when it doesn't fit as a function, we call it a relation. And then if it does fit the term of what a function is, then we call it a function. But the first thing is to get you to understand what a function is. And essentially it means, and I like to illustrate it this way, a function is when you think of it like this way. When you put an x coordinate in, 1x, you will only get one y value that comes out. As long as there's only one. You can throw two x's in for the same y value, that's okay. So you can have x1 and x2, but if you get one y value, that's okay. The point is that you only get one output, that there's only one corresponding y value. That's the thing. What you can't have, as an example, you can't have something like this. So relation, well, I guess not a function, so not function, not equal to a function, is when you put in an x value and it splits out two potentially different values. So y1, y2. That's when it's not a function. And that's as simply, if I were to sort of illustrate the idea to you, that's what it is. So in this example that I've given to you, technically this is not a function, or it cannot be a function, because you see, when x equals 3, I actually have two y values that are possible. I have at 3, I could get a 4, or at 3, I can get a 6. So that means when I put in the value x equals to 3, it will spit out either a 6 or a 4 as my result. This is not a function. So a function specifically says that for each x value, there's only one corresponding y value. Meaning, there's only ever one special y value. There can't be two special y values when you put an x in. that's I guess, the summary of that idea. If that's confusing for you to sort of visualize, they do teach a technique, and they say, well, another way to think of it is if you draw a vertical line down these coordinates, if it intersects twice, then that means it is not a function, okay? This is what we call a vertical line test, which is over here. They say you can do a vertical line test, can be drawn anywhere on the graph, and it only ever intersects the graph a maximum of once. So if it intersects twice, that indicates to you, if it intersects twice, that indicates to you that for one x coordinate, you're going to get 2 y values. That's what the vertical line test does. A lot of students just memorize this, so they don't understand why we do a vertical line test, and then they get confused between a vertical line test and later on you're going to learn a horizontal line test. So you need to understand why we do them, and really it comes back to this one concept. If you can just understand this diagram that I'm showing to you, it's the idea that for every x coordinate, there will only be one y value. We call that a function. This is why, okay, this is why when you think about why is there such thing as quadratic function, linear function, or cubic function, okay? Because if we draw each and every one of those graphs again, just to visualize, when I draw a straight line as an example, so a linear line, let's do a linear function. So this is a linear function, right? Can you see this line here? Every coordinate that you pick, so say I pick this point here, for one x value, there is only one y value. There's no 2 values for that same x value, and there's no more on that graph. If you pick another one, it's a separate one. For that x value, there is a different y value. It's very unique to it, okay? This is called a function. So this is a function. Whereas if you, and you can test this by doing a vertical line test too. So if you did a vertical line down, see, it only intersects once. Vertical line down to that point only intersects once. That's what a vertical line is, or what they call a vertical line test, but you really don't need to memorize that. You just need to understand that for every x coordinate, there is only one y value. So that's a linear function, which is why we call it linear. Sorry, that's a linear equation, so that's why we call it a linear function. And then same thing if I did another graph and I did the quadratic version, you can also see the same idea occurring. So watch, I want to draw a quadratic function. So I draw, let's say, that as a quadratic equation, right? Same thing again, for every point you choose, there's an x coordinate and then a y coordinate. It only has one x and one y that corresponds to it. This is a function, and you can test it again by doing vertical lines. As you're doing vertical lines, you can see it only crosses once. There's only, for every x-axis value, there's only going to be one y value to look at. When there is two intersections, that implies that you're going to have 2 different y values. That's essentially what that's trying to say. Okay, so what's an example that is a relation? And the best one to show you is what we call a square root relation. And let me show you why. Okay, let me show you why. When we do a square root function, see, when you learnt in chapter 4 square root function, this is what a square root function looks like. We draw it from here and it goes like that, right? But technically, when you write y equals root of x, actually this is not the true graph. It's actually a relation. If you actually sketch this properly, it shouldn't look like that, okay? And the reason why it shouldn't look like that, because if I put in x equals to 4, you would tell me that you would do square root of 4. So when x is 4, what is this value here? The y value, you see, square root of 4, most of you will say it's 2, but we know that every time you square root, it's either a positive or negative. True? So not only is it 2, it could potentially also be negative 2. But then why don't we see that point on this graph? And that's because when I'm teaching you square root function, this would ruin the idea if I drew this part here, this will no longer be a function. And another way to remember this concept is that this x squared graph is the parabolic version of it. And this is what we call the inverse version. And the inverse version, sometimes it is not a function. And that's part of what we're going to be learning in chapter 5. See, the x squared graph looks like this. Can you see how it's like a parabolic shape? Yeah, where the y-axis is, it's going up, right? Whereas the inverse version, it's sort of going this way. So the vertical one goes up that, and then if you tilt your head, the black graph is going across the x-axis, isn't it? But it essentially looks like a quadratic graph, but just on the side. So why don't we sketch this bit is because based on the theory, for the one x value, so when I substitute an x value of 4 into the box here, just imagine as the machine or the function, it actually ends up spitting out 2 values. You got y is equal to maybe 2, or y could be negative 2. And that is not the definition of what a function is. This is technically just a set of coordinates now. So a bunch of coordinates, if you draw them all in, this is an infinite amount of x coordinates and y coordinates. That's why we call this a square root relation. This is actually just a square root relation. Now what's beautiful about it, you can actually sketch this on a CAS. So I'll just quickly show you. If we go to the graph setting, you see we're conditioned so much that this is always by default sketching a function. That's why you're not able to see the square root relation. See, if I actually do square root and I type in x, right? When it sketches it, you only see the top half. But we know there should be a bottom half because square root of 4 or square root of 9, there should be a plus minus answer. So why do I only get that top part? And that's because by default, see, notice that's an f there. f3 means it's a function. Or 3 is just the third type of function. But what we want is actually we want to sketch a relation. So here, we're meant to go to menu, okay? And then you can go graph entry. See how there's a function and a relation? We've always by default been doing function without questioning, but in our case we want to do a relation. So if I actually now type in square root of x, okay, you should see now, whoops, I didn't do y equals 2. Oh, that's weird. They didn't do the, because that's a positive side, so they actually sketched what I wanted. I needed 2. How can I do this? There's a plus or minus button. I've forgotten where that is. There was a quick way to get there. Here it is, plus minus. So in the catalog, just above the division sign, there's a plus minus there. So here we go. Oh. Sorry, this is weird. Usually they sketch it for me. What's plus minus root of x? That doesn't make sense. It is a relation. Does it say parabola? No, circle, ellipse. Oh, weird. Well, I'm just going to illustrate my point by using 2 functions then. I'm going to have to figure this one out again. I might have forgotten how to do it on a CAS. So if we go back to a function, technically if I sketch the negative version of it, so negative the square root of x together, that's where your parabolic shape is. So this is the negative. When you square root a value, there should be a positive and then a negative version of it. That's what a square root is. That's the idea. But and that's when you call it a square root relation. But otherwise, if you put in the positive on the outside, you're saying that it will always be positive, hence why you would only draw the red graph, and then the negative is a reflection of that, and so that's why you get the bottom half. But technically, that's what it should look like as part of what a square root relation is. So this here is called a square root relation, and that's an example of we did a vertical line test. Okay, we did a vertical line test right there. We did a vertical line test there. You can see it crosses twice. Once and twice, that indicates that it doesn't pass the vertical line test, and therefore it is a relation. Okay, so that's an example of it. And technically we did circles as well. Circles is a relation. And that's why there are certain parts of what you need to know here is to understand how do you test for a function. I'll have the separate videos for the examples here, but that's essentially what you need to pay attention to. A function specifically is when you sub an x value in and you get only one y value. It's okay to sub two of the same x values, but you can only get one y value. So one of the best ways to sort of figure it out is to check. Do you get two of the same y values somewhere? Okay, so notice there's one y value, 2, 4, 7, and 6. They're all different. Therefore, it must be a function. Okay? Sorry, not a function. When you have 2, 4, 7, and 6, those are the one unique y values. But what's interesting is, are there similar x values? So for the one x value, are there repeated ones? So we can see here, sorry, my bad, I just said something that's confusing. Can you see how when you have two of the same x values, that implies that you're going to be substituting two for one x value. Sorry, let me do that again. For one x value, you will end up with two separate y values. So look for repeated x values. Okay, that's how generally if they give it in coordinate form. But I'll do some examples for you to understand. But essentially what I want you to take out of it, vertical line test, if you just draw a vertical line, if it crosses once on the graph, then it's a function. What is a function? Think of it as the y values that come out. There's only going to be one corresponding y value to any x value you substitute into the function. Okay?